Hi there. So my name is Philip. I work for Redis. I'm Portuguese, and I'm going to present in English. Today's talk is focused about, focusing on the Redis example of on how to optimize, on how we do optimize our database. But this can be, presented in an agnostic manner. So what our approach to do an end-to-end performance platform and an automated performance platform is focusing on our database as an example, but you guys can take the same approach and apply it to your products, and the outcome or the outcome would be exactly the same. And I'll start by the takeaway, or on one of the things that I wanted you guys to take home today is that first, if you don't measure anything that matters to your business, you can't really improve it, or you can't keep track of it and try to optimize it. And second is that the sooner you start measuring it and the sooner you start keeping track of it, the easier it gets, the less stressful it gets, the cheaper it gets as well, because solving a performance issue in production is way more expensive than solving a performance issue on the code development stage, and it's also easier. So to give a little bit of context about what we mean or what we do as the performance team at Redis, we work on the open source product and on company projects as well. Our main goal is basically to foster performance across all partners, basically us as a company, but also the community members and all, vendors that work around the Redis ecosystem, like AWS, Alibaba, Ericsson. So we all work together in terms of how to decide on how to first measure Redis performance, on how to keep the performance steady, and how to improve it over time. One conclusion that I believe that anyone in this room would be able to to do, or if they analyze their systems, if they analyze the code in which they work upon as part of their daily jobs, is that when we talk about functional testing, functional coverage, if my product is doing exactly what is meant to do, normally we have a good coverage. So I'm talking about the normal code coverage metrics. But when we talk about performance, when a problem hits production, when something is malfunctioning, or when we have high demand on our products, high demand on our system, then things start failing, and we have no way of automatically tackling or detecting it in an easy manner. So we normally wait for a customer or some metric from a production system to pop out, or to deviate from the normal behavior for us to detect the performance issue. And this could be done in a much more stress-free way if we attack the problem at the stages of code development. And to give you a real example of why this is so important, that it's not just about the maturity, or it's not really related to the maturity of the company that's basically developing the product. I can tell you as an example, I brought an example out of Redis of one of the products that we sell, which is Redis Search, that basically adds secondary indexing on top of Redis. And we are, as you guys might know, we are like a billion-dollar company, a huge company. And this type of issues still happen. And the issue, or the performance issue, is quite simple. It came out of as a business-as-usual task. We have a minor version bump. We want to compare a baseline versus a comparison build, and we want to assess performance. We want to see if bumping the product version will improve or degrade the performance. And back in 2019, this implied manual checking, implied us as performance engineers to deploy, two concurrent, versions, test version A, test version B, assess how and why did we improve or regressed. And what seemed to be like an easy task took, months until we finally reached a point in which we say, okay, we are satisfied with the end goal. We have reached a point in which we have 65% or 64% performance boost, but this started as a very stressful task. We started, this implied multiple patch releases, implied multiple times of doing manual code checking, manual code deployment, and the feedback that we, passed through between the engineering teams and the performance teams implied, siloed information, implied that we prepared a lot of data, communicated with them, They did the code changes, provided a new build for us to test, and we iterated over it multiple times until we reached a positive, let's say end goal or a positive outcome. But what this means is that doing this type of performance analysis on, let's say, a finalized product or a near finalized product is basically just buffering a lot of potential issues and making it a lot harder for us and for the engineering teams to act upon, let's say, the necessary code changes, or to first to understand exactly where is the performance regression coming from. So we said, okay, this is a very reactive way of doing a performance analysis, and this is, well, I would say that this is the normal way of doing it. And we wanted to, let's say, shift things around. We wanted to move to a more proactive performance analysis methodology, in which as soon as we are able to assess the performance of the product in a zero-touch manner, or in a manner that implied no work no manual work from the performance team or the development teams, we will start measuring it. Meaning that as soon as you push code to your Git repository, for example, we will then deploy the environments, assess the performance, destroy them, and compare it against a more stable version. This was the end goal. This was exactly what we aimed for. Of course, there were some requirements. Given that we were talking about automating it all, we needed to make sure that the outcomes of our benchmark tools would be deterministic. We needed to make sure that it was as less noise as possible, meaning that the noise will always happen. We just needed to make sure that we keep it tight as possible. We controlled it, and we were able to assess if the bump in performance, or a performance improvement, or a performance regression occurred because of the code change, or if something in my environment, which meant that we wanted to make the environment as steady as possible. Nothing changed apart from the code being measured. And this is not, I would say that this is not really disruptive, or at least this part is not disruptive. This is being done also by our competitors, like Elastic, Lucene, Mongo. We are all tackling the same type of issue, and basically the end goal is always the same. We want to make sure that we react as fast as possible, in the cheapest manner possible, and with the less manual work as possible to detect performance issues and to act upon them. And this is our approach. So basically, we partnered with multiple, let's say, hardware vendors. We partner with, let's say, competitors even. And we all agreed, okay, first let's decide on how to properly measure Redis. How can we assess with a set of benchmarks how to decide if a version is better versus the previous one. And then let's try to automate this as much as possible and make it easier for someone reviewing a proposal being done to the Redis code to be easily measured. And this is how we achieved it. So let's say that we are talking about a PR that's expected to improve performance or degrade it. A Redis maintainer tags that PR as something, or a PR with interest in terms of performance analysis. We basically added this tagging or labeling as a means for us to, let's say, not to waste computational resources. Let's assume that we are talking about a PR that's not affecting performance, or that we know beforehand that there's zero performance implications. We are not going to trigger all this automation. So we are just going to trigger this automation when we feel that we need more numbers. So basically, a maintainer labels the PR. The PR triggers a set of events that basically we have a standard spec. That set of events will basically build Redis into multiple manners. Given that we want to assess Redis performance with different configurations, we build it in different manners, and for each different build, we run all the benchmark suites that we have. And this means that even before, let's say, accepting or merging a pull request to a more stable branch, we are able to assess the performance multiple times. Each time we, let's say, a maintainer or someone from the community pushes new code to that specific PR, we are able to assess the performance and act upon it. And what have we gained from this? Well, given that we are talking about like a zero-touch way of measuring performance, implying like zero manual work, from the moment you push the code to Git, we are able to do a trend line, or we are able to assess the performance over time or by branch and by version of a specific, let's say, Redis deployment. And we're also able to tell you let's say, to do a scalability report in an automated manner. So let's say that you are talking about, for a specific use case, I want to assess what's the inflection point, or where, when does it stop making sense for me to add more and more processes or charts within Redis for this specific use case. We just need to, let's say, run it in that or in a deployment with one chart or one process, 3, 5, 15, 30, and then see the inflection point, or the point in which performance stops growing, or the metric that I want to optimize stops growing, and then we basically reach the point in which we, either are happy enough with the results, or we have a point to analyze and to act upon. And this is the interesting part, and this is the part that I believe that we are being disruptive with regards to, let's say, other competitors or other persons doing this end-to-end performance analysis. This is an example of how a developer can use or can trigger a local or a remote benchmark for one of the products that we have in-house. So bottom line, the overall idea is that you should be able to get the same look and feel when you are developing, or the same look and feel with regards to benchmarking when you are developing, as we do when we are, let's say, tracking the performance of your code within our CI system. So it's exactly the same way of assessing performance, either locally or in a remote, more stable manner. You should be able to, let's say, to try out what's the performance of the new feature that you are basically developing. This is cool because basically what we are gaining from the local benchmark runs, we are not using this for, let's say, stable performance assessment. We are using this for you to be able to easily add or extend the number of benchmarks that we run. This is all, let's say, local benchmark running has a different purpose than running in a more stable manner or in our CI systems. Local benchmark running is just for you to have an easy way of extending and, let's say, playing with the performance of the feature that you are developing. And then we can very easily assess, based upon the data that we are collecting, how stable is the benchmark data, and how have you improved or regressed the code for the different use cases. But the real interesting part is when we start making the hard questions. Is when we say, okay, we are not happy with the current performance, how can I optimize it? And the questions are not being made just by the performance team. This can be made by any of the developers within the Redis company or the community. So let's say that we have a use case 1, or a use case that's benchmarking Redis, and it's reaching 100K ops per second. And the developer wants to understand, what are basically what are the top CPU consumers for this specific use case? Is this, let's say, this top CPU consumer table making sense with regards to the specific, let's say, code that I'm developing? Are these specific functions expected to be hot or expected to be taking 30 or 40% of the CPU time of my entire system? We are basically allowing you to understand and to correlate a specific performance number, for example, throughput, latency, etc., with the on CPU profile data. And this is the interesting part. Then, as soon as you start associating the on CPU profile data and the entire, or the metrics that we collect from the entire system with the specific benchmark, then you can start making sense if it's, or you can start correlating them and assessing if this makes sense and if it can be optimized. So basically, by default, we, for every benchmark that a developer adds, we provide you out of the box with a flame graph, the normal, let's say, the correlation between the total CPU time, or in this scenario, with the on CPU cycles with a specific function. We can go a little bit deeper and associate a CPU cycle, or let's say the time that you spend on the CPU, either doing computation or waiting for memory, with a line of code. So this is quite interesting because let's assume that you have a function that's taking, or that's huge, and let's say the function granularity would not allow you to, let's say, very easily act or very easily improve. With the line of code usage, or with the line of code information, you basically, let's say, have a direct relationship between, let's say, the top CPU consumers or the top line of code that's consuming my resource, and try to optimize that specific line instead of having to look at an entire function. We also provide you in a more, let's say, aggregated view, telling you, for example, is the benchmark A, let's say, easily optimized, or let's say, is the benchmark A spending the majority of the time on my code, or on, let's say, a library that I'm including? this can be easily done by let's say, shared library report. And we also do, let's say, prepare some work for you to do differential performance analysis, which basically it allows us to, given that we have this profile information, let's say that we have version A and version B, with the identical steps collapse, what we can do is to differentiate them. And in the same manner that we do a flame graph, we can do a differential flame graph, and this is all automated. Assuming that the use case that you basically are assessing as a specific auth path, we also provide you with a call graph, let's say very easy way identifying what's the, let's say, the line of code that you should optimize. Up until now, so this is basically in place since 1 year ago. Some projects have a little bit more time, but I would say that the project with the majority of the usage has been running like this since 1 year. And up until now, we've gained up to 68% in performance on some specific use cases. Of course, that Redis has more than 400 commands. So what I wanted to tell with this line is that, well, as soon as we started measuring, and as soon as we started keeping track of the performance of Redis and associating with the profile data, we started finding, well, very easy potential points of improvement. What we saw before as an example of, let's say, a feedback cycle that took days for me or for the performance team to communicate with the engineering team, let's say, how is this version performing versus the old code that took days because it implied manual work. Now it can, let's say, take even a little bit less than 1 hour. 1 hour, 1 hour is the time that it takes for a full benchmark cycle to run. And now the interesting part is that it's not just us, the performance team, that's adding or extending the benchmark suite and extending the performance coverage of our products. Now it's everybody's responsibility because it's easy. Developers can do it and can feel more confident with the code they are developing. And bottom line, given that we are, let's say, automating away the boring work, we basically scaled our team, or we scaled our team to be able to devote time to the things that matter. So the automation allows us to do more challenging stuff and devoting time to more experimental things. And as I mentioned, now finding performance issues is not just, this is not just about the performance team responsibility. Now it's everybody's responsibility because this data is shared across the entire company. And it's very easy for us to do, for example, to be able to answer questions to product or to, let's say, to some engineering field that's asking a specific question like, we have a new AWS machine family, for example, the 66i. I want to understand if I bump or if I change the machine family from C5 to 66i, if I'm going to gain something out of it by default. So it's very easy for us to do this type of A/B testing, given that we are focusing on automation. Doing this type of work in a manual manner, well, implied a lot of time spent, and basically, well, implied that we deprioritize other type of work. Now that we can do this in an easy manner, we accept this type of tasks. It's very good also to have like continuous up-to-date numbers. We don't need to stop everything that we are working upon to provide numbers, for example, to marketing, to product, to engineering, to be able to do some blogging. And it's also very good for to foster openness. Given that we are talking about a benchmark suite that we all agree, and the benchmark suite that, let's say, multiple vendors and multiple partners collaborate with, we have a number that's, or a set of numbers that are a single source of truth. And so this is just the beginning. It's not a perfect system. Given that we are basically collecting a lot of performance data, what's next for us is basically to be able to not only focus on per benchmark, let's say, hotspots. The overall idea is that we aggregate the entire data and can come to you as a project or a team leader that's responsible for product A and assess and tell you, okay, for the 50 benchmarks that we have, aggregated all together, these are the kind of codes that have more impact. If you focus, let's say, your performance improvements there, you basically have the, let's say, highest possible impact in terms of the time that you are devoting optimizing the code. We are extending, let's say, we want to, let's say, keep extending the probes that we've had to the systems. We want to have like more visibility, given that we are talking about a product that has more than 400 commands. It's a huge effort to have full coverage. And we want to basically increase open source and company adoption. And the end goal is that we move away from our static documents or the static charts that you guys see when you let's say, check for the performance of Redis documentation, and you start seeing up-to-date constant numbers based upon the profile data and benchmark data that we gather. And that's it. I would like to mention that we have, well, anyone from this, let's say, crowd could be, can try Redis Cloud for free. So it's a $200 giveaway. Just ping me, and I'll send you the discount codes. And I think that now, if we have time for questions, no, okay, we can talk
yeah.
later.
Thank you, Felipe.
Thank you.
Thank you.